think a lot has already been said about Industry 4.0, so I think my presentation will sort of give an idea of how we can realize a way forward. So my topic today is towards big data-based integrated product service systems for railcar manufacturing enterprises. Now, we live in a world that is full of products. Just to give an example, in our own daily life, we have products such as we need food to be able to survive, we need clothing to be able to go outside and see people, and we need houses, shelter to be able to live in. So all these products that we use on a daily basis to be able to live or to do our work or to do whatever we need on a daily basis are made through processes. And most of the processes go through or start with the extraction of plants, which is what we call farming. And then that farming goes is taken through trucks and taken to a manufacturing environment where it's converted into a final product. So we have what we call farming or the extraction of raw material, and it goes to a manufacturing environment where it's converted into a product, or in other cases assembled into a product, and then it's taken into a retail environment where sales or an exchange of ownership happens. So now many companies have realized that it's no longer sufficient to just produce products. We need to be looking into processes of the future. Now, recently I had a chance to go to an Internet of Things forum, Internet of Things Forum Africa, where our various key stakeholders met together to discuss this Industry 4.0 that everyone is talking about. So people from industry, people from government, and people from academia actually came together to discuss how we can realize these new business models. And this Industry 4.0 has been described in many terms, in many countries. Like in Germany, they actually call it Industry 4.0, which is actually where it came from, as reported by the World Economic Forum. But if you go to China, they call it product service systems. But if you go to other parts of Europe, they call it the Internet of Things. So many terms have been thrown around to sort of describe what many people call Industry 4.0. So from me attending the Internet of Things forum, I was able to come up with two questions which I asked myself, but I would also want each and every person to ask themselves the same questions. Which the first question is, how can we respond to the fourth industrial revolution in terms of technology? And the second question is therefore, how can we respond to the fourth industrial revolution in terms of firm innovation and also startup strategies? Now, most of the systems around, I would like to use product service systems as my term for describing my work, because that's what I've decided from the start. So most of the product service systems that have been developed or are going to be developed going into the future are centered around cloud technology. Cloud technology, as you all know, is used to store data. So I've done a bit of research to sort of look at how do we gather the data. And most of the data is gathered through sensors. So there's different kind of sensors. There's temperature sensors, there's proximity sensors, there is sensors that are used for robots. So there's different kinds of sensors that are used to gather data for these kind of systems. So for my problem statement, I want to bring it now into the context of rail. I'm saying that public transport can be frustrating for passengers. Although it is cheaper and greener, it is frustrating for a normal human being who is using a train to sort of plan around the train, because they have to plan around the schedule of the train, but also because of unforeseen circumstances, the train can then break down, and then that affects the operation of the train on a daily basis. So some of the issues around the train is the breakdowns between major routes, the overloads of the trains, and also the maintenance and other issues. So therefore, the maintenance and the monitoring of the trains becomes an integral issue to making sure that the availability of the trains is maximized. So then if we're using preventative maintenance, we can then say that there's a lot of data that is gathered from preventative maintenance, but then how can we come up with a sort of an intelligent way of coming up with a condition-based maintenance that can then be used going into the future? So to sort of paint a picture of some of the problems within trains, as you can see the picture above is a train overload. The ideal situation is the one that you can see below, where there's comfort in our trains, but also we want our passengers to be comfortable. We want to come up with, or rather design, intelligent trains going into the future. And that's the goal with public transport. So to sort of go into detail or technical with the train, I mean, the train has got so many components and so many subsystems. But if we're talking in terms of maintaining some of these components, we can use a preventative approach where we can schedule to say that the train needs to come in for, maintaining the motor on a certain day, or the train needs to come in for exchange of the brakes of the train. So that's sort of a preventative approach that we can take, or just taking one section of the train and maintaining it according to the calendar. So my research objective is to investigate the relevance and the possible benefits of the product service systems by exploring the following issues. The first one is looking what are the current developments within developers' maintenance. And the second one is assessing the maintenance approach that is currently being used within the rail space, and then come up or develop a business model that can be used within railcar manufacturing. So from my objectives, I was able to develop this framework to say that looking at a particular asset within the train, how can we then maximize its availability? So if we're saying we're looking at the motor, how can we then look at the motor? By gathering the data. We can look at data from the power of the train, or if we're talking in terms of the brakes, we can look at the data within the vibrations of that particular train. Or if we're looking at the passenger information systems, like many doors within the train or intelligent trains, they have sensors where if you walk towards the door is able to open on its own because of those sensors. So from that data, we're able to come up with a way that we can look at the number of passengers going in and out of the train, and then we can make some recommendations based on that. This particular model is a model that is currently being used in Europe. They use it for fleet management of the trains, where they're gathering data from the train while it's moving. They gather data from the train itself, they gather data from various components within the train while it's running, and then they make decisions on how fleet is managed, or how we can bring in the train to change certain parts, brakes, and so on. So this is a methodology that I've developed to sort of solve the problem. So I'm saying that, as I already mentioned, that most of the product service systems are based around cloud technology. So then connecting a particular sensor to the product, using service, connecting with service actuating elements, and then gathering the data towards the cloud, coming up with a knowledge-based health assessment. We can then compare existing data and then use data mining algorithm which then feeds back to the physical world, and we can use that data to make informed decisions. This is what I'd like to call innovation based on combination, where data generation happens and data is being collected, it's being stored, data is analyzed, and then it's used for the benefit of the organization. This is a dashboard which can be used to view the data that is being used. So this particular dashboard is for a sensor, like it's an IPS sensor dashboard, where if you have a sensor, you can use this software or this particular method to look at what is the power, what is the voltage, and how the sensor is actually performing. And then from gathering that data, you can be able to monitor the health of that particular sensor. What are the cost implications of developing my system? It involves programming. So at some point, some programming needs to be done, and you need a system analyst. So the total for developing this kind of a system is close to 100,000. What are the potential benefits or relevance to industry? It improves equipment reliability. So from coming up with the data, from collecting the data and using it in an intelligent manner, you can improve the equipment reliability, minimize scheduled downtime, and reduce cost of asset failure. But also on a wider scale, by looking at some of the challenges that we're facing, you can use it to improve economic development and the quality of life. I know they say that most of the systems and the technologies around Industry 4.0 are taking away people's jobs. But I think we can find a way in which people can be trained to use some of these systems without taking away their jobs. So it leads to job creation and also improving the quality of products. And also the environmental factor. Most of manufacturing in the past has been based around producing more products. So some of the systems are more virtual. So it has environmental benefits also. So future work, I'd like to contribute to the development of Industry 4.0 within our country. I'd like to maybe possibly write a journal paper and collaborate with other engineers to innovate. I've written a paper for this conference with the help of my supervisors. So I'll be attending, by month end of May, attending this conference. It's on product service systems that other people in the world have developed. As you can see, there's many areas around product service systems, but my focus area is product service systems maintenance and service through life cycle. So I'll be attending this conference. Hopefully I'll be able to get some more information and come back to implement within our own workspace. Acknowledgements. I'd like to thank Tshwane University of Technology for giving me opportunity, and the Gibela and the NRF. Thank you.
Thank you.
If Gibela now is manufacturing the new trains, does it mean that they do not have the safety features in them? We are manufacturing world-class trains. Those trains, they have what Gautrain has. But why do we have issues around delays? Why do we have? So you will realize that the other part is the challenge with the operating model and the infrastructure that you have. I'm just preempting and trying to give you a guide. Né? So you will realize that although the train, you are taking a new train, but you are putting it on the old infrastructure, which has no signaling system that talks to the technology that is on the train. The same technology which we have in our trains is the same technology which our train has. Have you ever seen people burning trains because they feel they are late at Gautrain. The issue of data collection, it's already collected there. They have got a system that collects the data. So what I'm saying is, when we go out and do this research, we should also check what we have already in the country. It shouldn't be like we are going to do a research in other places where these things are not there. And I'm saying they are there. These case studies must be factored in within our comparisons.